Machine learning is the science of getting computers to learn without being explicitly programmed. Tom Michael defines machine learning as a computer program set to learn from experience E with respect to some task T and some performance measure P. If its performance on T as measured by P improves with experience E. To understand it better, suppose you have an email program which watches which email you are marking as spam, and based on that it learns how to better filter spam. Here T or the task equals classifying emails as spam or not, E equals watching you label email as spam or not, and P equals the number or the fraction of email correctly classified as spam or not spam. Thus we see that unlike traditional approach where our programs were nothing but long list of rules, complex rules which required maintenance, and plus the spammers always kept on working around the spam filters and we needed to write new rules forever. Here when you are using the ML approach, our spam filter automatically learns which word or phrase are good predictors of spam by detecting unusually frequent pattern of words. Thus the program will be much shorter, easier to maintain and more likely more accurate than our traditional approach. Another term that we come across is AI. AI stands for Artificial Intelligence. It is the theory and development of computer systems to perform tasks requiring human intelligence such as visual perception, speech recognition, decision making, reasoning, translation between languages or NLP, navigation. Next we will be talking about machine learning types. Machine learning can be broadly classified into three main categories depending upon whether human supervision is involved, whether it is learning incrementally, and the way it is generalizing the stuff. Human supervision based machine learning can be further classified as supervised learning, unsupervised learning, or reinforcement learning. When we talk about supervised learning, that is the learning where human supervision is involved, we basically talk of two types of algorithm. One is your classification algorithm and the other one is the regression algorithms. Example, classification of spam filter which we are talking of is a supervised learning task. In supervised learning, the training data we feed to the algorithm always includes the desired solution which we call labels. In classification, the spam filter was trained with many emails called training data. Each email in the training data consisted of a label. The model then learns how to classify new emails if they were spam or not spam. Whereas regression works on prediction. Example, if you want to find the price of a car, here we try to draw all the possible lines such that the lines fits the best to the data that is available to us. We try to minimize the error and we try to train the model in the direction leading to better result. Instead of drawing all possible lines, our system or the algorithms here make use of the concept of gradient descent. To understand gradient descent in a very simple term, we can consider ourselves blindfolded on a mountain terrain and our aim is to find the lowest point say. Since we are blindfolded, we will be deciding upon our last step. If our last step went higher, means we are in the wrong direction. In that case, we will go in the opposite direction. Otherwise, we will keep going faster and faster until we reach our goal. Next is your unsupervised learning. In unsupervised learning, the training data is unlabeled and system tries to learn without a teacher. It basically talks about the clustering algorithms, and to train such models we just need to feed the data set to the clustering algorithms, and at no point we are going to tell the algorithm as which group a particular thing is going to belong or what is the criteria upon which you are going to decide, or in other words, unlike the previous one, we knew our aim, whether our email is a spam or it's not a spam. Here we are not telling the algorithm what is wanted out of the data. It is the algorithm which is going to decide and filter or group the data depending upon what it can figure out. For instance, if we want to detect a group of similar visitors to our blog, we will just feed the training set to the algorithm. At no point we will tell the algorithm which group a visitor belongs to. It's the algorithm that will figure out without our help and it may notice things like, say, 40% of the comics lover read the blog in the evening, so means they can be kept in one group. Rest 20% say they read only on the weekend, they can be kept on another group. Thus the data help us in targeting our blog post for each group, but we are not telling the algorithm as the criteria on which it need to group the data. It is the algorithm that is figuring out. So basically, when we talk of unsupervised learning, it is the clustering or the grouping algorithms that we talk of. After that, we will be talking of is reinforcement learning. Reinforcement learning system can be thought of as an agent in this context, which observes the environment, selects and performs action, and gets rewarded and or gets penalty in return depending upon the way it is learning. Here too it learns by itself and tries to find the best strategy to get the most reward over time. Let's consider a few more examples of supervised, unsupervised and reinforcement learning and try to understand it further. The very first example that I am going to take is, suppose you are running a company and you want to develop and learning algorithms to address each of the two problems. Problem number one is, you have a large inventory of identical items and you want to predict how many items will sell over next 3 months. Problem number 2, you like software to determine individual customer account and for each account decide whether it has been hacked or not. So should you treat it as a classification or regression problem? Yes. The solution is that problem 1, which is the inventory one, is a regression problem, and the problem number 2 is a classification problem. Why did I say so? Because in regression problem we are trying to predict result within continuous output, meaning we are trying to map input variables to some continuous function, whereas in classification functions we are instead trying to predict result in a discrete output. In other words, we are trying to map inputs variable to discrete categories. Hence, problem number 1 is a regression problem and problem number 2 is a classification problem. Now consider a few examples of unsupervised learning. Unlike supervised learning, here in unsupervised learning, since we don't have labels or answers, we are just given data sets and we are not told as what to do with it. We are not told what each point is, where what we need to achieve. Instead, we are just told, here is the data set, can you find something out of it? Algorithm or us need to cluster the data or the group the data depending upon what it is able to figure out. Hence, the example which will be talking of in case of unsupervised learning will be something like news.google.com. Over here it looks at thousands of stories in the web and groups them into a cohesive news story. Or in case of social network analysis, market segmentation, where we are grouping customer into different market segments so that we can automatically group customer data sets and more efficiently sell or market our different segments. Or astronomical data analysis, these algorithms give surprisingly interesting useful theories of how galaxies are formed. Or another example we can consider is, say, a cocktail party algorithm. Over here we are having two group of people who are sitting at two places and we are having two microphones and both these groups are sitting in the same hall. Now what happens is, at the end when the party is over and we fetch the data from these microphones, both the microphones will have data of both the groups, but the microphone which was closer to group 1 will have clearer data of group 1, whereas the microphone which was closer to group 2 will have clearer data of group 2, and depending upon that it will filter the redundant data and we will give and we can get a clear voice information or the record information of as of what the group 1 was talking of or and what the group 2 was talking of. Next, if we talk of the reinforcement learning examples, the robot can be the best example that we can think of. Robot learning to walk by observing is the best example, or the Mario, the game of Mario, the way it learned how to play, how a system learned how to play the Mario game on its own by pausing, learning, getting the reward, and deciding upon with the direction it need to move. It's a perfect example of the reinforcement learning. And similarly, DeepMind's AlphaGo program, which defeated the world champion Lee Sedol at the game of Go, is again a good example of reinforcement learning. With this, we are done with the human supervision based categorization of machine learning. Next is when a system tries to learn incrementally, and the categorization on the basis of how a system is generalizing. Based on whether we are learning incrementally or not, we can classify machine learning into two main categories. One is your online and the other one is your offline or the batch. We use offline learning when system is incapable of learning incrementally. It is trained offline using all the available data. Thus, offline or the batch learning takes lot of time and computing resources, as every time the training that happens on the entire data. Whereas the online, in case of online, we train the system incrementally by feeding the new data sequentially or in batches. System can learn from the new data coming. It is good for systems where data is in continuous flow, like in case of stock prices, and it can be used to train huge data sets. Now the question that comes to mind is, what if the data is so huge that it cannot fit into a single machine? So in that case, what we do is we chop the data into pieces, or we divide the data into batches, and then use these batches to train the system by providing each batch incrementally. And although online or the incremental learning is always preferred, but it comes with a limitation too. Suppose we are having a bad data coming to a system, which can lead to the malfunctioning of the system or getting a system hang. In that case, we need to closely monitor the system and turn off the learning, and as soon as we detect something, some anomaly or the drop in the performance of the system. With this, we come to end of today's session. We basically talked about machine learning, which is subset of your AI or artificial intelligence. We talked about different types of machine learning, whether it's a supervised, unsupervised, reinforcement learning, online or batch processing. And we also saw that supervised learning includes algorithms, which are either your classification or the regression algorithms, whereas your unsupervised learning includes your clustering or the grouping algorithm. Hope you find the session informative. Happy learning. Thank you.